Welcome to AR Maths Pro Learning Academy. In this video, I am going to talk about relations and functions of class 12, and the topic is composition and invertible functions with some example questions, because on this topic we don't have exercise questions. So that's why I solve few example questions, which is 15, 16 and 17. Composite function. A composite function is nothing but combining two functions to make a new function. That's it. Let us define. Let f maps from a to b and g maps from b to c are two functions. Then the composition of f and g is denoted by g of f. It is defined by the function g of f from a to c, mapping from a to c, given by f of x is equal g of f of x for all x belongs to a. Composite function means combining two functions by putting one inside the other. That's it. Let us have some more details. We have a function from a which maps from a to b and another function from b to c. So here domain for function f, domain is a and codomain is b. Suppose I have a set a. In this one I have an element a. We get this element and put in function f, which gives a domain inside b, which is f of x. Similarly, function g, f of x, the value of f of x, we put in g of x, which gives g of f of x, which is in set c. So g of f of x, from where we got g of f of x? From set a. If we plug in the value of x in f of x, and then f of x turns to g of x. So g of f is nothing but mapping from a to c. So here domain is a and codomain is c. Example 15. Let f maps from a to b and g maps from b to c. The elements of a is 2, 3, 4, 5 and b is 3, 4, 5, 9, which gives to set c, which is 7, 11, 15. Are functions defined by f of x, f of 2 is equal to 3, f of 3 is equal 4, f of 4 is equal 5, and g of 3, g of 4 equals 7, g of 5, g of 9 equal 11. We have to find g of f, g circle f. First of all, let us draw a figure. Okay, this is set A, set B, and this is set C. In set A, I have 4 elements, which is given here, 2, 3, 4, 5. And in set B, 3, 4, 5, 9, 3, 4, 5, 9. And in set C, 7, 11, 15, like this. Now, defined by the functions f of 2, which means from set A, we have 2. And it substitutes in function f and gives 3. So if x value is 2, the function f is 3, like this. And if x value is 3, which gives the function f 4. If it is 4, 5. It is given in the question, check. 3 gives 4 and 4 gives 5 and 5 gives 5 as well. So 5 gives 5. Similarly, in function g, 3 and 4 gives 7. 3 and 4 gives 7. Okay. And 5 and 9 gives 11. 5 and 9 gives 11. We have to find g circle f. G circle f is nothing but g of f of x. At first, we have to find g circle f for all the elements of the set A. This is set A. So at first, g circle f of 2, and then g circle f of 3, and then g circle f of 4, and then g circle f of 5. At first, g circle f of 2 is nothing but g of f of 2. G of f of 2. And we know f of 2 value is 3. So in place of f of 2, I'm going to write 3 like this. And g of 3, we know that g of 3 is nothing but 7. G of 3 is 7. So g circle f of 2 is 7. Similarly, I'm going to find the second part, g circle f of 3, which means g of f of 3. And we know f of 3 in the question, f of 3 is 4. So in place of f of 3, I will write 4 like this, which is g of 4. And g of 4, I know g of 4 is 7. It is given in the question. So g of 4 is 7. So g circle f of 3 is 7. Part 3, g circle f of 4. G circle f of 4 is nothing but g of f of 4. And f of 4 value is given in the question. F of 4 is equal 5. So in place of f of 4, I'm writing 5. So that is g of 5. And g of 5 is given, which is 11. So g circle f of 4 is 11. Similarly, part 4, g circle f of 5. G circle f of 5 is nothing but g of f of 5. What is f of 5? F of 5 is 5. So in place of f of 5, I'm writing 5. So that is g of 5. And g of 5 is given in the question is 11. Finally, I got g circle f of 5 is 11. Now, write all these in roster form. G circle f of x is nothing but 2 gives 4, 2 gives 7, and 3 gives 7, 3 gives 7, 4 gives 11, 4 11, 5 gives 11. So that is our final answer. Question 16. Find g circle f and f circle g. If function f maps from R to R and function g maps from R to R are given by f of x is equal cosine x and g of x is equal 3x squared. Show that g circle f is not equal f circle g. So let us first of all find left hand side, LHS, g circle f of x. G circle f of x is equal g of f of x, like this. And in the question, g of x is given, which is cos x. So in place of f of x, I'm writing cos x, which means g of cos x. And g of x is given in the question, 3x squared. So in place of x, I will write cos x, which will be like this. 3 in place of x, I'm going to write cos x whole square. You can write cos x whole square like this, or you can write 3 cos square x. This is the value of g circle f of x. I have to find for the right hand side, which is f circle g of x. F circle g of x is nothing but f of g of x. And the value of g of x is given, 3x squared. So in place of g of x, I will write 3x squared, which is f of 3x squared. And we know f of x value is given cos x. So in place of x, I will write 3x squared. We just need to plug in this x value in this place. So it will be cos 3x squared. In place of x, I wrote just 3x squared. This is the value of f circle g of x. Now check. This is our left value and this is our right value. And they are not equal. That is what we have to prove. G circle f is not equal f circle g. Invertible function. Invertible function is a function that has an inverse function, meaning it can be reversed. That's it. In simple words, if a function takes an input and gives exactly one output, and you can go backwards from that output to get the original input, that function is invertible. Let us define it. If I have a function from x to y is defined as invertible if there exists another function g from y to x, such that, how can we prove that? G circle f is equal x and f circle g must be equal y. Then the given function is invertible. A function f is invertible and g is called inverse of f, and it is denoted by f inverse. G of x is equal f inverse of x. Note, a function is invertible if and only if it is bijective. Bijective means the function must be on 1 and on 2. Question 17. Let f maps from n to y be a function defined by f of x is equal 4x plus 3 and y belongs to n such that y equal 4x plus 3 for some x belongs to n. Show that f is invertible. Find the inverse. To find the inverse, first of all, what is given function? Given function is f of x is equal 4x plus 3. f of x is nothing but y. That's why I'm saying y equal 4x plus 3. Now from the given function, solve for x. That is your inverse function. Okay. Now solve for x means we switch positive 3 to the other side. It becomes negative 3. So y minus 3 equal 4x. Now I need x. I don't need 4. So I divided by 4 on both sides. So y minus 3 over 4 is equal x. Now this x is nothing but g of y. So g of y is equal y minus 3 over 4. This is our inverse function. Now let us show that it is invertible or not. Okay. To show whether it is invertible or not, g circle f of x is equal x. It should be equal to x. So g circle f of x is nothing but g of f of x. And I know what is g f of x. F of x is nothing but 4x plus 3. So in place of f of x, I will write 4x plus 3. So g of 4x plus 3. And we know g of y is y minus 3 over 2. G of y, this is g of y is y minus 3. So in place of y, I will write 4x plus 3 in place of y, like this. Check, in place of y, I just wrote 4x plus 3. And I have negative 3, I wrote negative 3 over 4 over 4. And here I can cross out positive 3 and negative 3 becomes 0. So the remaining is 4x over 4, and this 4 over 4 you can cross out. So g circle f of x is equal x. Similarly, we have to prove f circle g must be equal to y. F circle g must be equal to y. F circle g is nothing but f of g of x. And we know the value of g of x. G of x is nothing but y minus 3 over 4. That is g of y. So g of x is nothing but y minus 3 over 4. So in place of g of x, I'm writing y minus 3 over x, like this. Now, this is in the form of f of x. And f of x is given 4x plus 3. F of x is given 4x plus 3. So in place of x, you will write y minus 3 over 4. Y minus 3 over 4 here, like this. Check, in place of x, I wrote y minus 3 over 4. So here 4 and 4 you can cross out. Okay. And the remaining part is y minus 3 equal y minus 3 plus 3. This is minus. Okay. This is minus. So here positive 3 and negative 3 cross out. So y is remaining part. So f circle g of x is equal y. So I got it. So f is invertible. And we know that, so the given function f is invertible. And we know that g of x is equal f inverse of x. And g of x is nothing but y minus 3 over 4. In terms of x, it will be x minus 3 over 4. That's it.